And with that, I'm going to turn around and introduce Jeff. He's going to be our speaker today, and he'll go ahead and give you his bio and stats. And
yeah.
Round of applause for Mr. Jeff this morning.
Thank you. Appreciate it. Now, can everybody hear? Good. Okay, so I've got a little bit of a cold, so every once in a while I might have a little shocking cough in there. I'm very apologize, but that's the way it happened. So I guess I by way of introduction, since there was no sort of bio, I can tell you how I got into this business. I'm actually retired ASHI member, but I was been in ASHI for 30 years. And I invented a machine to remove lead paint, and I started a contracting business in the 80s to try and sort of develop this thing. And actually they were in Massachusetts when the lead paint law first came out. There were only 3 legal ways to remove lead paint. One was to scrape it. You know, they'd hang a banana on the wall and get a gorilla with a scraper and kind of lower the banana. That was one way. They destroyed all the trim. You know, everything came out flat. And then you could use chemicals, methylene chloride, and then the third method was my method. So I thought, you know, gee, I mean, what more could you ask for? So I was in the law. I had the crew, and we did a lot of paint stripping, and the machine was too slow. It was really terrific. The people in the art restoration business loved it, but it was way too slow. So I didn't know what to do then. I had to do something else. I had been a teacher, a chemistry teacher, and my wife was a broker for a while, and she said, "Why don't you become a home inspector?" And I said, "What's that?" I had no idea. I'd never even heard the word before. And she kind of hooked me up with a couple other ASHI members, and I went around with these guys, and I was hooked. I mean, I knew that was for me. I loved it. So I took my PD class with John Cox, who was an unbelievable teacher, and then I came back to Boston after the class, and I did my first home inspection. So, of course, this is before the days of licensing anyway. So I did home inspections for about 20 years, and then sort of transitioned over to doing indoor air quality. I started taking some courses, and then I did home inspections, indoor air quality at the same time, and then eventually sold the business to the fellow that was working for me, and then started just doing air quality altogether. So my background, I have a degree in chemistry and actually a graduate degree. So that was really my background as a scientist, and so I really like what I'm doing now because it takes a lot of science. So what's different about what I do is that I look at my own samples, all the samples. Those are just, I save them for 7 years. I have thousands of slides, and they're all pink because I use a pink stain. If any of you have seen any slides before, sometimes they're blue. Those are people who use a blue dye, and that's why they're all blue. But mine are all pink. And I love what I do. I spend a lot of time looking at, I look at all my own samples. I don't think there's maybe only 2 or 3 people in the country that do that. And I hope I don't bore you with, excuse me, the samples. Home inspectors love pictures of things. You're showing people, what you saw. And so, I'm trying to get a little bit of enthusiasm. So try and be patient with me because it's important to know what I know. I had to see what I see, and so this will really, I think, help you a lot in your practice. So how many of you do mold sampling, mold testing? So quite a few. Okay, good. So So this whole concern about mold started, you can actually date it to 1995 when Dr. Dor Dearborn discovered that some babies that had died had Stachybotrys in their lungs. And this became very, very controversial. And the CDC kind of eventually hung them out to dry, and things sort of died down a little bit. But, could we turn the lights down a bit? So this was an article in Redbook. So right after that, there was a lot of hysteria, and everybody got concerned about mold. But this is really the beginning. And I don't know if you can how well you can see this, but that was Bianca Jagger, Mick's wife, and she got sick. Mold destroyed my home. And there's a picture right there. And what is that? Can you all see that? What? It's what? You can. Okay, that's just efflorescence, right? So that's the picture they showed. Mold destroyed my home, but and she did get sick. So there was a lot of, this is several years later, and it goes on and on. I actually visited the house where this woman, I can't think of her name now, in Texas, which started the whole thing. It was something Springs, and they tore the house down, actually. So, there's been a lot of stories, media stories, and, every environmental concern has a similar history, and that is, people say, it's a big deal, and then everybody comes out and denies it. And so, really, mold exposure has always been a health issue, and it's just really nobody recognized it. So it was a great thing that hysteria happened, although it kind of got out of hand. So there are a lot of references, and I'm not going to go over these, but there are a lot of references, very good references that talk about the health effects of mold exposure. So it really does make people very sick. It can. So, but there's a lot, and what I'm going to do is I'm going to go over a little bit of there's a lot of crazy stuff, so I'll go over a few of these crazy things. Information on the internet is not all that reliable. So here's a quote from Doug Hoffman, executive director of NORME. He says, "Bleach does not kill mold." Now, maybe some of you have heard that. That is idiotic. It's like gravity makes objects jump off the surface of the earth. That's the equivalent physics. So there have been, numerous studies, and bleach is very effective in killing things. And the CDC says bleach kills viruses, it kills bacteria, and it also kills mold. So here you see this was a study they did. 2.4% of bleach is kind of high, actually. In a bottle of bleach, it's 5%. So this would be only diluting it up halfway. So that's a little stronger, I think, than most people would care to use it. But it certainly does work. So now we'll talk about some little fungal facts. I had some fun with this. So that's a Halloween, Thanksgiving, what is it, Halloween? I guess Halloween, pumpkin left out too long. So what fungi need. They need moisture, oxygen, and a food source. And of course, you got to be in the right temperature. And a lot of people say mold can't grow when it's cold. You open up your refrigerator and you take the jelly out, or the pasta sauce that you had in there too long, and it's just covered with mold. So it definitely can grow at low temperature. And there are a lot of misconceptions about mold. So this is actually in the background here. We should mention this. This is a photomicrograph of Cladosporium, and that's the most common mold worldwide. And this was from somebody's house. It was an air sample. I think it came out of a heating system, but I'm not sure. But this is the hypha, and then this is called the conidiaphore. It's the spore-bearing structure, and those are the actual spores. So there are many different species of Cladosporium, and this is just one. And this is actually a really unique situation. You rarely ever see the entire structure, the conidiaphore, coming out of in a sample, but usually just see the spores. So Another big myth, and I don't know how many of you have actually told your clients this, but I see it all the time. Mold destroys buildings, and these are wood decay organisms, and they destroy buildings, but mold fungi do not. So there's two big groups of fungi. One is called macrofungi. Macro means big, and then micro means small. So the macrofungi, mushrooms, the spore-bearing structure is very big and visible. And microfungi, the spore-bearing structure, which I showed you earlier, the conidiophore, it's microscopic. You can't see it. So macrofungi are wood decay organisms. Microfungi are not. And so mold is not a wood decay organism. Period. There are a few exceptions to that, but you can't, you could have this whole place full of mold and there wouldn't be one single structural defect resulting from that. The spores cause health symptoms. So here are the macrofungi. That was a mushroom in a basement, a wall I saw. The other slide on the left there you see those are mushrooms growing on the plywood in a crawl space. And you all see this, probably almost on a daily basis when you see wood broken up into little sort of cuboidal sections like that. People call it dry rot. It's not really dry rot. It's just, it's caused by wood decay fungi, macrofungi, that digest the wood, and they do so in two different ways. I don't think we'll get into that. But, and then these are microfungi, mold, and you see that picture on the left there. I couldn't believe this was the front door to a house, and they had high humidity in the house, and the door gets cold in the winter, and there was mold all over the door, but you couldn't see it. The mold that's growing there, it's probably penicillium mold. You couldn't see it because it's colorless. And it looks white for the same reason that snow looks white. If you think about it for a second, water is colorless. It's completely colorless. If you chop water up, the more you chop it, the whiter it gets because it's reflecting light. And eventually you get to a snowflake and it scatters the light. So all the light that hits it goes off in all different directions and it looks white. So colorless things can be white. So when you shine the flashlight, and I always tell people to do this, on your inspections, you shine a flashlight on a wall at a very oblique angle, and then the mold will just light up because you can't see anything unless you have that bright light. So, as I said, microfungi are not wood-destroying organisms, period. So you can see mold all over the place. It doesn't mean that anything is being decayed or destroyed. It's ugly, it stinks, and it causes problems, but not wood decay. So these are some of the common genera of fungi. You got Stachybotrys, Aspergillus, Penicillium, Cladosporium, Cotomium. So they only cause surface growth, with the exception Cotomium causes something called surface rot. Like if you have a wooden post buried in the ground, it gets kind of mushy, and that can be Cotomium. And you've all seen Cotomium. It's a black mold. It's growing on drywall paper that's been wet. And the other black mold is Stachybotrys. And if you see black mold, it doesn't mean that it's toxic black mold. I mean, Cladosporium is black. There are dozens and dozens, probably hundreds of black molds. But what's interesting about the Stachybotrys Cotomium is that they both need very, very moist conditions. And so often you'll see this, you pull the baseboard off of some drywall in a basement where there's been floor water, and you see black mold, and you look behind that and there's more black mold. Well, the black mold on one side could be Stachybotrys, and then it might be Cotomium on the other side because the moisture conditions are different. And mold does not grow through plaster, through drywall. That's a ridiculous notion. There are no nutrients in the plaster, and it's too dense. The hyphae couldn't go through. So it's two separate growths if you see it, but it's always telling you that there's been floor water and it's soaked up in the paper. And that's why when they install drywall, if you're doing new construction, you want to make sure that the drywall is about 1/4 of an inch up off the floor in the basement. Excuse me again. So They talk a lot about Stachybotrys and cellulose, and I suppose it does grow on cellulose, but a lot of times on paper there's actually starch sizing in the paper, and the mold is actually growing on the starch rather than the cellulose. So we covered that. But this is actually interesting. This is from the Missouri Department of Health, and it says structural damage is caused by mold. So there's a tremendous amount of poor information out there. And then you hear this thing, mold is everywhere, and that's really not true at all. I mean, you can probably find some mold growing in any house, but there's not necessarily going to be exposure to the spores. So the mold spores are everywhere, but the thing to keep in mind is that it changes tremendously the concentration. So in January, February, you have very few spores, and then it peaks in the summertime, and then it drops off again, and you have all different molds growing at different seasons. If you're doing sampling, if you're actually doing those aerosol samples at a house, in the wintertime, there's nothing outside. It's nice to sample because whatever you see indoors in a structure, that's all from indoors. When the ground is covered with snow, there are just no spores outdoors, virtually none. All you ever see is carbon soot from diesel and from combustion from oil. And then road salt, believe it or not, there's a huge amount. When you're driving down the highway after a big storm and it's suddenly gotten sunny and dry and there's sort of white cloud, and I can actually taste the salt. And when you look on the microscope at the sample, you'll see little cubical crystals of salt. And then you put the medium on top of that, the salt all dissolves, so you never really see it unless you look at it dry. So you don't need to do an outdoor sample, although I suppose technically, that somebody might insist, why didn't you do an outdoor sample? But so here's some statistics. You don't need to look at just the yellow stuff here: ascospores, basidiospores, cladosporium, and penas. So the lab reports that you get, it's just overwhelming amount of information. But the only thing you really need to look at, I think, is the ascospores, basidiospores, penas, maybe aspergillus or penicillium spores, because the most important thing to understand about this is that ascospores come from outdoors, and so do basidiospores. And I guess I'm not even going to bother with that one, but wait a minute. Okay, there. So this is an example. That's cladosporium growing on a leaf. And they call that mildew. There's all these different mildews that grow on plants. The downy mildew and, peach mildew, strawberry. A lot of them are cladosporium. That's Cladosporium herbarium. And those are spores in the air of the Cladosporium herbaceum. So that's an outdoor type of mold that you also see indoors. So the main molds that you see indoors really growing are Cladosporium, Aspergillus, and Penicillium. And when I look at a lot of these reports from other people that I get, people ask me questions, that's really almost all that I care about, because it's the Aspergillus or Aspergilli and Penicillium that grow indoors. So now, those are called basidiospores, and your report always in the summer, let's say, or in most seasons, you'll have many, many, many basidiospores, because the mushrooms are everywhere. They have very significant release mechanisms for the spores, and they're very small. They can be confused with other things, and that picture on the right there was amazing. That was mushrooms growing out of siding on a house. It was actually a home inspection. I couldn't believe the homeowner came out. He said, "That wasn't there last night, I swear." and actually it's true. You know how the mushrooms, like the biggest mushroom on record, so to speak, is somewhere out in Oregon, I think. And it's we wrote a book called The Mold Survival Guide, and it's one of the little facts in there, but it was 1,500 acres of hyphae underground. So you can imagine that one single mold organism can be tons and tons and tons of material. So now when the conditions dry suddenly and the fungus decides to sporulate, overnight you get these mushrooms because there's this huge mass of moisture and nutrients underground. And these are ascospores. Now, ascospores grow on leaves and apples and things like that, and so that's what the ascospores look like. I actually have gone, there's a thing called Spore Camp, and I've been there like 3 times now. The Pan American Aerobiology Association runs this Spore Camp, and you go out in the woods and you look at things and get samples of things, so it's, for us nerds, it's really fun. So the other really big division here in the types of fungi that you want to understand is that they're the so-called phyloplane fungi, things like Alternaria, Cladosporium, Epicoccum, and probably many others. And they grow on leaves and fruit, so they produce mostly, ascospores and Cladosporium. But if you see them indoors, it's due to infiltration. So I've only seen once Alternaria growing indoors, and Cladosporium can be either indoors or out. Epicoccum is always from outdoors. And there's another one, Pithomyces, it's always from outdoors. It's never from indoors. So the phyloplane fungi grow on things that are in the air, and that's why there's so many spores in the air. On the other hand, you have the soil fungi, which are the Aspergillus, our Aspergilli and Penicillia, and the difference, the soil fungi are in the ground, so they're not going to be aerosolized as readily unless it's windy. So you very rarely see a lot of Penicillium or Aspergillus spores in the air. If you do, it's because the lab didn't count right, and we'll get to some of the problems with the laboratory analysis. But soil fungi, they grow in leaves and they grow underground, so they're not as ubiquitous as the phyloplane fungi. So if you can remember that, that's important facts for when you're interpreting these mold reports. So the main indoor sources of mold are air conditioning, carpets below grade, and then building materials that are wet. And they tend to be the soil microfungi. So you won't see phyloplane fungi growing indoors unless somebody has a moldy plant or something like that. So I did a study where I looked at reports from 600 homes, sick homes, and then I looked at 300 homes from just sort of home inspections. And one of the facts that I discovered here was that, let's say in Boston, because it's an old city, only 18% of homes have central air. Now, today, 100% of new construction is air conditioned. But 36% of the sick homes had air conditioning. So that's telling you something. It's almost twice the rate, because you have what you need in air conditioning. You have what you need in order to get mold growth. You have moisture from condensation, and you got dust from the house. And that's how you get mold growing. And then the same thing, carpets, finished carpets basement carpets in finished basements are often full of mold because they have very damp conditions at the floor. So here are some pictures of different pieces of equipment full of dust and moldy dust in most cases. You like this filter? And then ducts can get moldy, but not generally. The exception is duct work. This is taken by a duct cleaner, but this woman had severe asthma. That's all skin scales with mold colonies growing on it. This was a duct that went through a crawl space, and the crawl space, the conditions in the crawl space can be below the dew point of the ambient air in the summertime, and you can actually get condensation, and so you can get mold growing. And then this was the dust in a return, and it's mostly, again, that dust, it's mostly skin scales from people, and then if they've had pets and things, it'll be dog dander and lint. That's what holds everything together, the lint from our clothing. So air conditioning coils are almost always moldy. It's really tragic. It doesn't affect everyone, but I should say the only sort of exception to that, if you're in a desert area where you have air conditioning, there's not a lot of moisture in the air. So when you're cooling the air, you're not really getting condensation necessarily, and so it wouldn't be that much of a problem. But in the south of the country where you have high humidity, and on the East Coast, you have the same situation. So most air conditioning is a problem, and that if it's interesting here, you can see what the coil there should look like. We're very at the bottom, and the reason it's not moldy there is because there's no dust that got accumulated on the coil because of the condensate pan there, the lip. And again, same thing. There's over and over and over again. And the only way to prevent, and this is really important for your clients when you're doing the inspection, they have air conditioning, especially if they have allergies, that you have to have a good filter, because you can't stop moisture from an air conditioning system because you're getting condensation. There's always going to be water. And so the only thing you can do to prevent that growth is to prevent dust from getting in there. So I always recommend the big, 4-inch, 5-inch deep pleated media filters, and those things work great. So, and then we said, so in addition to air conditioning, we had moldy basement carpet. So this is a scanning electron micrograph of carpet, and this is the cross section, and that's the base of the carpet. Now this was a new carpet, and it had a terrible smell to it. And I was actually sitting there with the microscopist looking at that sample, and we couldn't find any mold. I thought, this is so weird, because I always assumed like the dust settles into the carpet at the bottom, it gets damp and it gets moldy. But then I said, just for the fun of it, let's look at the tops of the fibers. And when we looked at the tops of the fibers, that's where we actually found the mold growing. So that's a cellulose fiber, and that's a cellulose fiber from lint. But these very thin things are the hyphae, and there's some mold growing. So it's like ivy on a telephone pole. This carpet was 2 weeks old. And what happened was the condensate pump on the air conditioning broke, and some of the water went under the carpet. There were no nutrients, no dust in the bottom of the carpet on top of the, I can't think of that word there, but they were growing on the fibers. So high humidity also in basements causes a lot of mold growth. And when you see kind of even, this is a key thing, when you see a lot of just evenly spread out colonies like that, it's always telling you it's just from high humidity. If there are stains and patterns, loop-de-loop, curve things, that's from water movement. So this is telling you and look at the rust on that shutoff for the oil for the system. It's all, been high humidity, a lot of rust formation. So this was behind a bed where a kid was having a lot of asthma, and that was due to condensation. That pattern in the corner it was very cold in the corner. It was a masonry wall, and people did, there were 5 people, I think, living in the house. They took showers, they did wash in the house and dried things, and so there was a lot of moisture, and it condensed. The other one, the door there, you'll see that. Again, that was not visible unless you shine a light at a very oblique angle or the flash from the camera. But that's aspergillus growing on a kitchen cabinet. They probably had moisture inside the cabinet, and it grew on the door. And if you open and close that, you get huge numbers of spores in the air. So while we're on that kitchen cabinet, I actually opened up a kitchen cabinet door one time, and the entire back wall was covered with Stachybotrys. There was unpainted drywall. Water was leaking behind the sink. And I thought, well, this is interesting. So I put my sampler inside the cabinet, and I opened and shut the door a couple of times, and there wasn't one mold spore, Stachybotrys, in the sample. So Stachybotrys mold is not very readily aerosolized. It has to be disturbed. It has to be, let's say, in a carpet or in some place where it gets knocked around. Otherwise, you rarely see those spores in the air. Now, with aspergillus, it's exactly the opposite. If you I'm allergic to some of these aspergillus species. If I were to just go like this once, I'd be choking from that. So that's the difference. The spores are very, very readily aerosolized. So here's the Stachybotrys from leeks. And you see that a lot, and you can tell the water, the mold is growing up higher, closer to the source, and then as you get further away, it's less because the water is soaking into the paper. And when I do my investigations, and this is for those of you that do this, when I do an investigation, I'm usually there 4 or 5 hours, and I check the bottom of every single piece of furniture in a house, because very often there's a lot of mold on the bottom, and where it's really sort of tragic is if it's the bottom drawer of a dresser. And when you open and close the drawer... Problem?
Question.
Oh, question. Okay, yeah.
Good morning, Jeff.
Good morning.
If we're kind of back to the air conditioning system.
Yeah.
We've been taught that the air conditioning system is a natural moisture reduction system, dehumidifying system. Would it be a true statement to say that because someone did not run their air condition, say let's say I'm from Jamaica and we don't like air conditioning down there, we like it warm. Because I didn't run my air condition, that's why I got mold growing all over the place. Would that be a correct statement?
I would say that if you have high humidity, which you do, that would be a fair statement, because it's a separate. Air conditioning does reduce the relative humidity. The water that comes from the air ends up in the air conditioning unit, and so you then get the mold in the air conditioning unit instead of the wall. So mold can grow at very high humidity. For example, that mold on that furniture there, that's never been wet. It was probably stored in a damp basement, and then the mold just grew at high humidity. Molds can start to grow at around 90% relative humidity. So, there's a lot of remediation hype. There was a $30,000 carpet removal. And, I actually looked at a house where this was amazing. This guy is a very famous pianist, and in December he went to give a series of piano concerts in Italy. He was gone for 11 days, and he called his air conditioning guy to please make sure that his humidification system and heat was working properly, because he had 5 very expensive pianos in the house, and the relative humidity has to be 50% in order for these things to stay tuned. So inadvertently, the technician, turned the humidifier so that it was running continuously. So he came back. This is with a house from 1830 or something. So he came back to his house, and he couldn't open the front door because it was, swelled shut. And I looked at the thing. There was mold on everything, absolutely. And there's pictures in the book of some of the things I saw there. It was incredible. All the shoes, the walls. And this was 11 days of very, very high humidity. So he got estimates for the cleanup. One company wanted $100,000, one of them wanted $60,000, and the other one wanted $20,000. So if you have clients that are getting estimates, you might tell them to ask around. So they cleaned up the house with $20,000, and I think it worked out fine. So you often see people, they have that efflorescence. What happens is, water comes through, it dissolves the minerals, or it contains the minerals. When the water evaporates, crystals form, and then pushes the paint off, or, you see a coating of white stuff. So this guy came into this house, mold tester, said they had mold, and it was efflorescence, and they were, it cost them about $4,000. So there's a lot of unfortunate stuff going around. So the biggest source of mold problems on home inspections, you guys, I get a lot of calls, referrals from home inspectors. They found mold, or they think they had mold, and because you can't say that in your report. And it's typically attics and basements. Those are usually, unless there's a leak, but mostly those are the problems. So, this is all mold it's usually on the sheathing, in our part of the country anyway, and the mold's black. It's never Stachybotrys, because Stachybotrys can't grow, it's not wet enough, but it's usually Cladosporium or one other mold, which I can never remember, Euclidium. Those are the two typical ones that are on the sheathing. And you rarely find those mold spores in the house because, as you know, the stack effect, air goes from the basement upstairs and then into the attic. So you hardly ever do. And the one time I got involved in a situation like that, I don't know if I have this later on, but this mold inspector or home inspector took a sample in the kid's bedroom in a house while everybody was marching up and down into the attic. And what happened was they had a high spore count. The cellar was devastated. And when I came in, I took a sample, didn't open the attic, and there was no mold at all in the air. So when you open an attic, in the winter anyway, you have all the warm air from the house going up, but you also have huge amounts of cold air sinking down. There's a big convection cell. So you have to be very, very careful. If if it's a moldy attic, you want to do your sampling before you open the thing up. And you rarely, if ever, will find samples from an attic inside the house because it's isolated. Yeah.
Quick question. I get lots of calls regarding what people conceive as black mold on their windowsill. Now, I know that any mold can be black, or not any, but anyway, is there a typical type of mold that is?
That's usually cladosporium, and it's totally meaningless. I mean, you just spray it with a little bleach and wipe it off. I mean, you don't even need a mask, really. This is a very important point about mold. When it's wet, it can't be aerosolized. People are so freaked out by it, but, I mean, I'm very allergic to this stuff. I've had that a million times, from condensation on my windows, and I'll just spray it with a little, bleach detergent solution, and then as soon as it's wet, you just wipe it off. It's nothing. Yeah.
Jeff, you mentioned just a few seconds ago that as home inspectors, we cannot say that it's mold. Why can't we say it's mold, and what are the ramifications if we choose to?
Yeah, well, you can say, it's a mold-like substance or something like that. That's what a lot of people do to get around. But the problem is, I often see things that I can't tell if it's mold or not. I have to take a tape sample and look under a microscope. There are situations where you can be sure it's mold, but there's a lot of them where you're not. And so the safest thing is to say it's mold-like or, something like that. But you really cannot say for sure whether something's mold unless you look at it under the microscope.
So can we say that it appears to be mold?
Yeah, it appears. You can say that too. Whatever appears like, that's fine, as long as you don't say there is mold, because now you're committed to that. Okay.
Thank you.
Yeah.
Quick question. I see this in attics almost every day.
Right.
When you see this, what would you tell a client, and what would you recommend?
Well, that doesn't really upset me a whole lot. I mean, it can be, there's, remediation for that type of situation. The newest thing now, which is easy, they spray it with hydrogen peroxide, and that basically, bleaches the thing and kills everything. What you want to keep in mind, there's so much like so-called overkill. The mold spores are relatively, delicate, and so in a sample like that, and I'll talk about this later, you take a sample of that, and you might find 1 out of 1 million spores that are alive. The spores, they die from, so we know what the temperature is, 140 degrees on the sheathing, right? It's going to kill just about everything. So when you have billions and billions of spores, a few of them will still be alive. So, killing something like that doesn't make sense, but it's ugly as hell. And so they spray it with peroxide. I always recommend also sealing everything, because if there's any residual allergen left, that just seals it into the wood. It'll never be a problem again. In a situation like this, if they re-roof, you'll often find, a lot of mold in the fiberglass, and then the fiberglass probably should be replaced because there's a lot of spores. So that, again, when the spores are dead, they can still be allergenic. So they may still be an exposure or a health issue. So basements, and this goes to your question, in Jamaica, you have high humidity in basements, and mold just starts to grow on everything. It grows on dust. I've seen mold growing on mirrors, on safes, and filing cabinets. The mold, it's really funny. Wherever people touch things, they leave their fingerprints. So fingerprints are amino acids and fats and skin. And so the mold just grows in that. So you see where where there's mold. Actually, I'll tell you, this is one of the grossest things. I was at a class where they were talking about a huge problem in a library, I think in Brazil, where the air conditioning system broke. Everything was, covered with mold, and there was a computer keyboard, and there was only mold growing on the J. And they could never figure out why the mold was growing on the J. And I raised my hand. I said, that's because the typist was right-handed and picked their nose with their index finger. You remember that one? So I've seen it on, it's sad, exercise equipment. You can't, again, that mold doesn't necessarily show up unless you have a bright light, but that can be really, really serious exposure issue. Yeah.
The last slide had the MVOC, mold VOC. Can you speak to that?
Do what?
Can you explain that?
Oh, MVOC, mold, volatile organic compounds. Yeah, the molds, some molds produce smell. And and others don't. So the smell, some people think it's unhealthy. It's a big deal. I frankly, as an organic chemist, have been exposed to every chemical on Earth probably, and the amount of MVOC from any mold growth is really pretty small. But we have a very low odor threshold for some of those volatile organic compounds, so they really stink. And there's a really good connection between your sense of smell and your brain, so people can, become symptomatic from the smell. But it's not an issue. I mean, you can test for it, but I would say in most cases, you can have mold growth, massive mold growth, and there's no smell at all. I had one situation where the guy, this was an architect who bought this mansion on Battle Street in Cambridge, and he gutted the thing and redid it all, and he thought he was being very clever. He put all the fan coils in the closets and he lowered the ceiling height, so the access to each thing was this big. It was so stupid. There was no way to even change the filter, and this was an architect. So he was very sick. He couldn't sleep in the bedroom in his house, and the smell was unbelievable, musty, moldy smell. And I took an air sample with a petri dish, and there were 7 cladosporium colonies, and they were all the same. And that's always telling you something. If you see a lot of colonies that are identical, then there's usually local growth, because from outdoors it's all different spores. So that petri dish, I've had petri dishes with hundreds of mold colonies sitting in my office, no smell at all. That one petri dish had the worst BO ever. It's like people, some people stink, some people spores smell. So that one petri dish made my whole office smell with 7 colonies. So it can indicate mold, but not necessarily. So I'm very sort of antiquated. I use a Burkhardt sampler for glass slides with grease, but most people today use these aerosol cassettes. That's really non-viable type of sampling. It's not culturable. There are different types of sampling. We'll just briefly go over that. How are we doing here? So this is called an Anderson sampler, and this was the sampler that everybody used, years ago, and it's held together by clips. This metal plate has 400 holes in it, and it divides the airstream coming up into 400 little streams, and they kind of impinge on the agar, and then you let that incubate for a bit. So that thing cost, just that little Anderson sample cost about $2,000, and then there's a less expensive version, this Burkhardt thing, which is portable. It has a battery, and you can use that for culturable sampling as well. And then there are other types of samplers. You just attach it to a vacuum for dust, and you can there's other sampling devices that you can attach to an ordinary pump, but that if you wanted to get dust, no, that's not for air. So now, just to evaluating and comparing samples, as I said, you get all these names. It's very, very confusing. And this is from David Gallup talk. I borrowed that, but so just look at the circles. So Cladosporium 693. This is in a complaint area, And then in the non-complaint area, it's 107. That's telling you, and this is, by the way, this is a total, non-viable. This is using an aerosol. It's telling you that, you probably have a problem because you have so many more cladosporium here. Now, outdoors, it's like 1,600. Now, there's a lot of people that would say, oh, gee, your cladosporium is, less than half. Indoors, there's no problem. But there is a problem. It's different cladosporium. These are this would be the phyloplane, the outdoor cladosporium. This is the cladosporium that may be growing on an air conditioning system or elsewhere. So, and then here you can see PenAsp. I always tell you, you look at the PenAsp, and that's really, really high compared to outdoors in the non-complaint area. So, I think in my experience, and as I said, I've done all these thousands of slides and air samples. If you could eliminate Aspergillus and Penicillium from the indoor air, you'd probably eliminate 80% of all of the problems. Stachybotrys is a rarity compared to the PenAsp. And now this is the culture testing. This is using something like an Anderson sample, and here you can see there's Aspergillus species versicolor, that's the one I think I'm really affected by. And again, it's much higher. This is the complaint area than the non-complaint area, higher than outdoors. This cladosporium is much lower than the outdoors. And then there's Penicillium. So the thing is, when you use a petri dish, you can actually see whether it's Penicillium or Aspergillus. So when you're doing spore traps, you cannot distinguish by looking at the spores if it's Penicillium or Aspergillus. They're almost identical. So here we see that most of the so-called PenAsp spores were in fact Penicillium and not. Well, actually, no. I take it back. There was both. It's a mix. Okay. So there's a comparison here, just to give you an idea that, remember the spore trap gave us 36,000 spores per cubic meter. The complaint area didn't have any, and outdoors it was only 107. And if you look at the cladosporium, we had, the spore trap, the culture plate was 106, so it's a sixth about of the spore trap. But you look at this, how dramatically here you see the difference. So for cladosporium outside was 1,653, and let's see, where was it? I'm getting mixed up the numbers here. I'm getting floating around too much. But my point, I guess, is that you remember the spore trap was 36,000 PenAsp, and outdoors it was only 107. So that is a huge red flag. And inside, look at the difference. All of these spores are dead. Only 130 of them grew on the culture. That's 130 per cubic meter instead of 36,000. So you figure the percentage of there, it's minuscule. Whereas, look at the cladosporium, the spore trap was 1,600, and outdoors was 1,000. So typically, the outdoor spores, the phyloplane spores, will be more likely to be alive because they're just maybe recently released by some type of growth. Indoors, the spores tend to be dead. Yeah. Okay, he wants to know which is better, the spore trap or the culture. Well, if you're trying to do an inspection to see if there's mold, you want to do the spore trap because it's very quick and it tells you the live and the dead spores, whereas the culture method takes a week and it's only going to tell you what's live, and there's a big problem with that because a lot of the symptoms people have indoors are from dead spores. Yeah.
We ask if you have a question to come to the microphone because the class is being recorded. Thank you.
Okay, I repeated the question. Thanks. Okay, so This is a really good dramatic example. This was in a university where there was a couple of people having some allergy symptoms. This is the inside of a fan coil unit, and it's obviously been wet. It's stained. All that black stuff on the coil. This is all mold here. It's all cladosporium. So this is a mess. Okay, and I took sort of a tape sample or a swab sample from that, and I also did culture testing. So if you look at these slides here, this is the microscopy, and all the dust was mold in that whole inside of that thing. Now from the swab or the culture testing, there was 3 mushroom spores and 2 Cladosporium cladosporioides. So Cladosporium cladosporioides is one of the molds that grows in air conditioning. And so all the mold is dead, everything's dead, but it still has that allergen in it which can affect people's health. So you're looking at your situation, the question you were asking, is it better to do spore trap or culture? You definitely want to do spore trap. If you want to determine the species present, then you have to do the culture plate testing. And I do that because, let's say somebody has some kind of very serious respiratory health issue, and they've been referred by a physician, and they want to know what species are present. So you need to do that culture, and you may not see it; they may all be dead, but it's the only way to see the species. So most of the spores indoors are dead, so spore traps are good. Tape sampling is very, very useful, and as I said before, you see a stain, you just don't know if it's mold or not mold until you sample it. So if it's really obvious to me, I won't take a sample. But if I have a question or if I want to know what kind of mold it is, then I'll take a sample. And the way I do it, I don't know how most people, I use a sandwich bag, and I put this blue tape, and then I take my tape sample and I stick it under the tape. And the blue tape prevents one sample from contaminating another sample. I learned the hard way. And then you can do settle plate testing, but that's pretty useless. A lot of homeowners do that. They'll stick a thing out. Mostly you're going to see only live spores, and again, most of the time it's going to be the stuff from outdoors. So for buyers, they want to know if it's a healthy house or is there a mold problem. And I don't think, air testing may not give you the answers to that at all, because it depends if the spores are in the air or not. If there's mold growing in a wall cavity, you may not ever see a spore there. So there are, risks to air sampling. And, I don't think, I'm sorry to say that, I don't think you should be doing it as part of a home inspection, because it really increases your liability. You may not see this. You may have a big mold problem that's not visible. Air samples can be meaningless, and I'll show you why in a second, but you get false positives, false negatives, and you can even we've had situations where something happened between the purchase and sale and the closing, and there was mold growing. So, it's if you have questions, it's a good idea to recommend somebody else to do that type of testing. You can do it if you want, but I think you have to be you got to really protect yourself in your, in your agreement for the mold test, that, you just have to make it clear this is just a snapshot, it's a picture of the air, it's not what's in wall cavities, et cetera, et cetera. It takes a lot of, limitations on that, but you want to be very careful. I got to tell you this. I got a call a couple of weeks ago from a woman, a very well-known attorney in the Boston area, 20 years ago. I looked at her house. Her 2 kids had this horrible autoimmune disease. They ended up getting their intestines taken out, and I found there was a rug in the children's room, and there was a custom-made wool rug, and it had the 2 kids' names in a crossword fashion like that. And that rug, what I do is I take a pat sample, I tap the rug like that with my sampler, and I collect the dust. That dust sample from that small rug had every microorganism that I've ever seen. I couldn't identify it. It's as if that rug, at some point in the manufacturing or whatever, was sitting underwater in a high humidity environment. It was just it must have been wet because there were algae. So I told her immediately, I said, you have to get rid of this rug as soon as possible because it's full of all this microbial growth. So when she called me up recently, she said, you murdered my children. They had all this surgery. You never told me about the mold in the house and blah, 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 blah. And, she said there was, what happened was that they put in a new shower when they bought the house just shortly before I got there. And when they installed the copper pan, I've seen this before, they put nails in the bottom of the copper pan. So she showed me pictures of mold growing, underneath the pan and said, this is what you did to my kid, So you really have to be careful in this business. I mean, the mold couldn't ever be aerosolized from behind the tile. I mean, it's nonsense. And I hope she doesn't. She's an attorney, so I hope she doesn't decide to sue me. But there's no case. So we said buyers want to know. A sick occupant wants to know, is there something making them sick? And, as I said, I get a lot of referrals from physicians, and, that's what I'm trying to do is to find out if there's something that might be in the air or whatever, something that, so air testing can certainly answer that. And again, as I said, the biggest health problem is this penicillium or aspergillus. So, I'm looking to see, if there's a link, the mold is present, could that be causing the symptoms? So, again, we said musty odor is not, absence of musty odor doesn't really mean anything. And a lot of times we get calls from people who, they've been chronically ill and then they go on vacation for a couple of weeks and then they're fine and then they come back and they get very, very sick, and that that sets off a little alarm. They finally realize that maybe it's their house or their office that's making them sick. So I think and I've been saying this for years. I mean, I think that home inspectors as a group, know more than anybody about buildings, and you could know more about air quality very, very easily. So I was actually on the national board of the Asthma Allergy Foundation, and the only reason I went on there was because it's called AFA. I wanted AFA to join up, with home inspectors, and to come up with a protocol and send home inspectors out. And I actually did some training classes for home inspectors to do this, and to be able to figure these things out. You see some of these reports from people who only do, microbiologists. They only do mold testing. They're out in the field, or even industrial hygienists, and they know nothing about buildings. You guys know everything. You walk in, and in a matter of minutes, you can figure out, what the potential problems are. And one way you could, I've seen this a couple of times, is this healthy home checkup. They have a booth downstairs. I got a couple of their brochures. That's a start. You don't have to look at your own samples. It's a lot of fun if you do, but you can send samples out. And this healthy home thing check doesn't even really include sampling. Yeah.
Jeff, sometimes I'll go in a house and after about an hour and a half, my eyes are just burning me.
Yeah.
What is it?
What is it? I'd have to take a sample. I don't know. It could, you may have some, allergy. That sounds more like an irritation than, allergy would be itching. So I'm not sure.
So I couldn't say. Could not be a mold problem?
What?
A spore problem?
A what?
Would not be a spore problem?
No, not necessarily. It could be, it could be. That's the thing that's so confusing about exposure to mold. Everybody has different symptoms, Some people get rashes, some people cough, it's across the board.
Thank you.
Anyway, it's a great thing, I think, for, in the winter, in the summertime, businesses are rather busy in the summer. The winter is a little more dead. That's a good time to get involved in this type of work.
So I had, there was a house I investigated that had evidence of water problems, and no visual staining of mold or anything. Similar, walked out with a headache, feeling pretty bad. I had done sort of indoor air quality VOC with a mold VOC test, and it came back clean. could that just be that there's still mold samples, spores?
Well,
I mean,
yeah. Okay. So
no,
they could be. It could be mold spores. It could be something else. The thing is, it's difficult to tell always. But you both raised a good point. And I was never embarrassed to put on a mask because I was so allergic to so many things. They used to call me the masked home inspector, and my other moniker was Jeff Dismay, which I thought was really clever. But I would put on a mask if something bothered me, and I think that for you guys too, if you're in a situation where it might be a problem, you should really you should wear a mask, an N95, and sometimes a respirator.
Okay, so I was surprised when the indoor air quality test came back with no mold VOCs.
Okay, because I'm sorry, I didn't really answer that. So the MVOC really only refers to very specific organic chemicals. And, that could be xylene or, gasoline fumes or something, but it's not MVOC, so they didn't report it.
Okay,
so when
this one actually was also included MVOCs. Could there still be spores, inactive spores?
Oh, absolutely. You can have tons of, I said this, you can have, that 36,000 spores per cubic meter and have no smell whatsoever. Oh, yeah, sure.
Hey, Jeff, real quick. So if we're doing an air sample test when the relative humidity is below 65%, it's in the wintertime, it's dry, will we still be able to pick up spores in the air test, even though they're not growing?
Absolutely. Yeah, it has nothing to do with growing, and I'll show you in a second what. Yeah.
Yeah, I was wondering if we could maybe get a sample of your mold inspection agreement.
Yeah, it isn't. Sure, it's not it isn't too terrific, but it's. I think you need a much better one. You need a much better one for doing real estate, because you see, people are living in the house, they're sick. I didn't cause the problem. They're not buying the house, so I think you really need an agreement that's different from mine.
Okay. Secondly, what's your opinion on when you put in a sample through the drywall and shove it up the drywall and take samples there? Okay,
so that's a in-wall sample now. The way I do that actually is because in real estate you can't make a hole. So what I did was I took a little, like a sandwich box, not a Ziploc, maybe it is Ziploc, or Glad plastic box, and I made a hole in it and I put the sampler there and I go over and I put it. Sometimes what I'll do is I'll bang the wall and vacuum it to get all the dust out of the electric box, and then I'll put the sampler there. Bang the wall and take a couple of samples that way, because those through-wall things, you get mostly drywall dust. The microscopist can't analyze anything with all the drywall. So you can do that through an electric outlet, and that's actually sometimes very useful. I've found a lot of, really big mold problems in wall cavities that way. It's in basements mostly, but you may not necessarily see the spores because you're only testing a very sort of small area, and it could be the next bay over. So you're only testing one bay where that outlet is. So there are some guidelines out there. I'm not going to really go over that, but there's a couple. EMSL has one, and because it's very difficult because there's not a lot of agreement. They've changed these numbers, and the most important thing if you're dealing with sick people is that you can't use these guidelines. If you're allergic to a particular mold, the numbers mean nothing, really. I mean, if it's a mold problem, yeah, there's an issue. But I've had people who there was like 100 spores per cubic meter, and they're having health issues. And the way to think about it is this: the range is like bee stings and peanut butter allergy. Like there's people could be stung all over from bees and have nothing, and then somebody else gets a sting from one bee and they drop dead from anaphylactic shock. Remember about 5 years ago, there was a woman, her boyfriend kissed her and she had peanut allergy, and he'd eaten a peanut butter sandwich and she died. So, kiss of death. Not funny, but so really these numbers don't mean anything for people who are really sort of hypersensitive. But in terms of, I suppose you need some guideline, and you can turn to some of those other things in for the home inspection report. but you got to be very careful. So, culturable sampling only tells you what's alive. Most of the stuff is dead. The non-viable, like the aerosol, only tells you you can't tell species. Tape, you're only removing the surface. I just had this problem the other day where I took a tape sample from an old, it was the sheet, in the 30s, I guess, they used, at least in our area, they used the subfloor for the form for the concrete, and then they put it, up to the ceiling for the subfloor, and you see all that concrete. And I took a sample, and all I got was, concrete crystals in my sample, but there was mold up there. I know there was. So sometimes even the tape sampling is problematic. So now I've seen reports. This is interesting. If let's say a school has, teachers are sick and they hire some company to do mold testing. I saw the school report. They did 100 swab samples and there was no mold anywhere. Why? That's right. There was no mold where they swabbed. They're working for the defense. I had that situation myself. They said, there's no mold in the carpet. You could see the mold in the carpet. They took a sample from the other side of the room. The judge had these two reports, and he said, look, this report says there's a huge mold problem. This one says there's no problem. And he said, you got to bring your doctor in. This poor guy lost his livelihood. And they couldn't get the suit because the doctor wouldn't testify. Okay, so sampling conditions are very important, and this is something you really want to keep in context. Here's some more nuttiness. So the best way to evaluate the significance of the indoor air is to compare it, to the outdoor air. And, it's useful to do that, but it can actually be meaningless. And so I'll show you why. And so we said, the spores, the allergens can last for years. You see the school's okay. Indoor concentration is a third of outdoors. But if you ever see elevated penasp, that is a problem. And this is really the key thing. When Penicillium and Aspergillus is growing indoors, you always see chains or clusters of spores. You'll see like 10 spores, because when the conidiophore, the spore-bearing structure for Aspergillus and Penicillium, they're like chains. You see like hundreds and hundreds of spores in a chain. They're very, very friable. If you go like this, they'll be aerosolized. Like I'll sometimes go to a surface and just wave my hand, and then I'm choking from what's coming off. So it takes very little air movement to aerosolize the spore. So if I see 10 penaspores in a chain, there's a mold problem indoors, because those chains do not survive the agitation in the outdoor air. And none of the labs report on the chains. They just count everything. And so it'd be totally, totally meaningless. And I would suggest, I'm sure coming to this, but I got to it now, that you want to only use a lab that tells you if the spores are in chains or clusters, because you are nowhere if you say, the penasp is less than outdoors. Don't worry, because if the spores, even though they could be 1/10 as many spores indoors, if there are chains or clusters, there is mold growth in the indoors. Yeah.
You mentioned a second ago that if you were to drill a hole in the sheetrock and stuff, that you get too much dust, so you can't really get a good sample. Because when you're out doing mold sampling, say I'm using a thermal imager, and I can see there's a lot of moisture in that wall, and I really want to get a sample on the back side, is there, you could take like a carpet one and do the outlet, maybe do a few outlets. But if you drill a hole, when you're doing a mold sampling test, you could ask the homeowner, is it okay if I drill a small hole? Could you do that, then wait a while, and then get a better culture?
Well,
or air sample?
Yeah, okay, so you can drill a hole. I just do it the way I do it because I don't want to make holes. You could drill a hole. What's really important is you have to wet the drywall before you put the. See, the problem with that is that when you drill a hole, you make a huge amount of gypsum dust, and so you're really screwing up your sample right there. But if you wet it, you'll reduce the amount of stuff that you're going to see. But if you have an existing hole like a electric box, I think that's a better way to do it. I don't know of a way to make a hole like that where you're not going to make a ton of dust. And really, when you get a dusty sample like that from a wall cavity with drywall dust, it's hard to see anything.
Can you use like some surgical tubing to put on the end of your sampler and push it in a little way so you're past where other?
Oh yes, that's what you have to do. Yeah,
That
they
would
make
be a-
samplers like that with a tube and everything. Yeah.
Right. So.
Yeah.
Okay,
No, I mean you
thank
can try it, push it away. Yeah. But the best way is not to make the hole. Yeah. Good.
You've made reference a couple of times about some of the chains and such. Do you actually bring a microscope with you and look at some of the stuff on site, or are you dependent on hopefully that the labs are actually giving you a little bit more in-depth detail?
Okay, so what I do all of my own microscopy. So I always know whether there's chains or clusters, and there's like maybe 1 or 2 labs that do it. There's I think it's Wei Tang is the guy's name. He will report whether there are chains. I've talked to all the labs. I've explained this to them, and possibly EMS. You should ask your lab. Say, I want to know if there are chains or clusters of Penaeus spores, because just the number there is, I can promise you, it's useless. Yeah.
Will you explain the difference between saying if the chains are present and that hyphae are present?
I'm saying what?
The chains are present and that hyphae are present?
Oh, hyphae. Well, okay, the hyphae are the root structures, and I have pictures of that too coming up, but the chains are the actual spores that are the reproductive seeds, so to speak, that go into the air. The hyphae are just the sort of the growing roots, and you don't usually, you see a lot of spores in the air, but you won't see the hyphae so much because they are actually in the substrate. They're kind of buried in the substrate. But you do see hyphae in air samples, but usually they're from outdoors. They're brown and big. Another really important thing, I got to say this, you can't take an air sample in a house if you've been in a crawl space or in a moldy basement, because you are covered with spores. I learned my lesson that way because I had a real estate, I think it was a real estate transaction. The broker said, oh, I just want you to check something in the attic first. So I went up to the attic and I looked at it, and then I went back. So this is like a multi-million-dollar house on acres of land, and they had the living room was maybe half the size of this room. There was a bridge in the middle of the living room, and there was a stream. Thank you. Thanks. There was a stream with fish going through, and then there was 3 prayer rooms with rice paper doors. It was like an ashram. So I took an air sample in the living room, and there was fiberglass fibers in the air sample. I couldn't believe it. I said, this is impossible. It can't be. So I looked at my knee, and I had a little spot on my knee where I had leaned on a duct in the attic, and I took a tape sample, and it was all fiberglass. So I contaminated the sample. So if you go into a crawl space or a moldy attic, you're going to get mold all over you. And now you take your air sample, and it's totally meaningless. So be very careful. I know they were trying to get pest control people to do mold sampling, and I thought that would be totally ridiculous. Yeah.
So with that being said, if you're going to do a mold sample as part of an inspection, it's best to do it at the beginning before you're disturbing.
Absolutely. You want to do the sample. I take my samples, I don't open the door to the if I want to know what the occupants are exposed to, I don't go to the basement, I don't go to the attic. I have clean clothes every day, and then I do all my samples in the house, and that way I know that I'm not, contaminating anything. So this was a really great situation. Actually, one of the home inspectors has a condo in Florida that he rents out. And the people who were living there had a mold inspector come and take some samples. And there, as you can see, he actually provided pictures in his report, which I thought was great. So there's his air sampler. This is the living room kitchen area. And you see the PENASP count there was 200 as a control. I guess outdoors it was 300 in the master bedroom, and it was 4,400 with that kitchen air sample. And so he said, oh boy, there's a mold problem here. The people's withholding their rent. It was very contentious. And he said, what? So, he came to me, he said, Jeff, what can I do? So he sent me the report, and I looked at the pictures. So this is the guy's writing. He said, hyphal fragments, baby spores not yet identifiable. I mean, that is like so unbelievably ridiculous. The guy doesn't know what he's doing. And so he recommends, professional new sporing, baby spores. I mean, the whole thing is just absolutely idiotic, and he shouldn't be doing this. But what happened was, if you look at the numbers, this was the really key thing when I looked at the numbers. So he said the air conditioning system was making them sick. And what I looked at, and I said, look, in the master bedroom, it was only 300 penasp, and it was 4,400 in the kitchen. So how could it be from the air conditioning? Why would it be different in one room than the other? They had to be high in both. So I said, that's not the problem. And if you go back to the picture, it was the rug. I said, that's it's a moldy rug, and that's why it was high. I said, tell them to get. So the home inspector had them take the rug up and wash the rug, and they did also clean the air conditioning and heating system because it did need to be cleaned. And that was the problem was solved. So all of the mold was coming from the rug. So you got to be careful. So this is an example of this is an example. This is a slide strip of a room before hitting the bed, and that's what it looks like. This is very low power, maybe like 100 magnification, but those are lint fibers and skin scales. And this is an Allergenco sampler, and it's got a little trolley, and it takes an air sample every 10 minutes for 5 minutes. And this is what they call log decay. So this is right when I hit the bed, and then you can see how it decays. So the point here is that what you see in the air at any given time is 100% dependent upon the state of agitation. So if you take a sample where people are walking around and there's 10 people in a room, you're going to get a huge number. And if it's quiescent, you get nothing. So let me just finish this point, okay? So this was a real estate deal. They had remediated this crawl space, and so there's the air sample in the upper right at 200x. You see my pink stain on the skin scales, no mold spores. And I just went like this to the crawls. The first time I put it down very carefully. The second time I just went like this with my notebook 3 times. And the spore count went up to 17,000 per cubic meter. So you tell me, is there mold in the crawl space or no mold? So the point is, the takeaway, if you want to know what's in the room, it's really what's in the dust. And you've got to somehow disturb the dust. I used to take 2 samples, a quiescent sample and then an agitated sample. But then I realized I don't really need the quiescent sample. I only need the agitated one, and that's going to tell me what the people are exposed to if there's a little bit of commotion in the room. Yeah.
Can you comment on, I guess, the presence of plants in the house? Because I've done sampling, and people have been complaining of being sick, and in certain situations, in certain areas where the plants were, there was a lot of, I guess the sampling was higher, the spores were higher, and is this a problem?
I haven't, really seen it to be a problem. I think because, all the clay pots, they always have mold on the outside because it's a damp condition from the soil moisture. And I suppose you could have, ascospores growing on the leaves, the phytoplankton mold, and maybe they're releasing the spores. I mean, on one of my spore cam trips, we actually looked at a leaf, and there was an it's called an ascocarp or something. It was a little bump on a leaf, and you could actually see spores shooting out individually. It was amazing. So yes, you could have more ascospores, but and you wouldn't have more basidiospores because there's mushrooms, unless there's mushrooms growing on the plant. So, and the soil fungi are in the soil, they wouldn't be aerosolized. So whatever mold was there might have been in a carpet, but it wouldn't. I haven't seen it. I have seen problems, and I had that picture, where people water a plant and the carpet gets wet and you get mold in the carpet and mites. That's when the wife is away and the husband has to water the plants usually. Yeah.
You brought it up several times. I was wondering if you could expand on it a little bit. I personally live out in the desert, so I'm not in a high humid area. But you brought it up several times about finding a lot of mold or mold-like substance in carpeting. But some of the things that you've shown are more not less the permanently installed, but like the throw rugs or like the area rugs and such. Could you expand on that just a little bit?
Yeah, well, if you're in a dry area, chances are you wouldn't be seeing that problem in rugs. But if you had a damp slab, or the way you have a damp slab in a basement, or if it's been washed. I mean, I suppose in your area, if the carpet was washed and it stayed wet too long, then you could have a very, very significant microbial problem. And I see it all the time. A lot of times if you look at a carpet and you see like a little rust spot where maybe there was a filing cabinet or a chair that had a metal leg, then you know that stayed wet too long. Yeah.
I have a question for you. I perform mold inspections and I do the air sampling, and I'm collecting the air samples in the biocassette. Do you recommend, after listening to you today, to actually take like your notebook and wave it around?
Yeah, I would. That's very. I would just. Yes, absolutely. I would say that you can. What I usually do is I walk around and I wave my notebook. What I don't want to create an unrealistic disturbance, but I want a realistic disturbance. And so by walking around and just waving a notebook, that's what people would be normally exposed to.
And then for the exterior sample, for the control sample, do you recommend doing the same scenario?
No.
Waving around outside?
No, you don't. Outside, whatever's in the air is in the air.
Okay.
Yeah. You just have to be careful where you put it. I put my sampler one time in a place, and there were mites. There were actually mites in the sample. I couldn't believe it. And then I noticed some feathers in the sample. And then I remember there were some turkeys that walked by my sampler. And the turkeys had mites, and that was what it was from. Yeah.
Because we always do an outdoor one as a baseline or a sample. I live in a very cold area in Alaska. It's cold. Can I still do it when it's, say, 20 or 10 degrees? Does it affect anything?
Yeah, sure you can do it. It's just you won't see anything really. Most of the plants are dead. Everything's kind of dead. But it's worth doing. But in those conditions, whatever you find in the air, it's going to probably be from indoor growth, unless it's basidiospores, which are mushrooms and they grow outdoors, or ascospores, because you'll always see some residual spores from other seasons.
Right, because I was wondering if it was even worth doing, like when there's snow and ice on the ground.
No, if it's snow, it's complete waste. No need.
Don't even.
No need.
Thank you.
Yeah, I'm a little concerned here. You've had several home inspectors stand up and tell you about their air sampling, take an indoor sample, take an outdoor sample, and what the lab told me is on the indoor samples, you're looking for spores that aren't in the outdoor sample. And then one of your slides said that as home inspectors, we shouldn't be doing air sampling.
Well, I mean, what I meant by that is I just think that if you take an air sample, the homeowner who's buying the house will say, do I have a mold problem? Is it healthy? And you take an air sample and there's no Penas spores and you say, yeah, don't worry, the house is fine. That's just not enough. You know what I mean? You have to, if you want to do a more thorough, testing, you want to test some pieces of furniture, the rugs, the mechanical system. You want to figure out, if there's mold, where it's coming from. If you're only there once and you just take an air sample, you have a risk of really missing a lot of problems and giving people a false sense of confidence.
So you're recommending really expanding our sampling?
Yeah, I would say so, yeah. I mean, that's the alternative, is to do more sampling, and then you got to figure how long is your home inspection going to take. But finished basements always have mold problems in the carpets. 95% of them have mold. And you want to take your sample near the foundation wall because that's the coldest, dampest place. If you take it in the middle of the room, chances are you'll get no mold. And if you take it at the perimeter, you're going to get mold problems. So,
Oh. Well, at some point in your presentation, tell us what we should be doing.
Well, I'm sort of saying, you agitate the air. You can take, this is as part of the home inspection. It's very, very difficult because you can't, you don't know where to stop. You don't know how thorough to be. And that's why I'm saying, it's better to have somebody else do the whole thing yeah, reducing your risk, yeah.
that is the point I want to make, because I've been doing home inspections for almost 25 years. Is this on?
Lift it up. Yeah.
Is that your height? So I've been doing home inspections for 25 years. For the last 10 years, I've been working with an indoor environmentalist. When I do inspections and I find evidence of possible mold, I'm not doing an evaluation. There's no way I have time to go through this house and figure out what's going on. It's a totally different approach. I have gone into many homes where the home inspector pointed something out, and I got into that house and things went crazy on what I found. The inspector just found a small part of the problem, and so maybe people are thinking, I've just got this one area, and sometimes it's been the entire house. So you could be inadvertently misleading people.
Yeah, that's sort of my point, is that that's the risk.
You cannot evaluate the house on a home inspection. I don't do it. It's a totally different approach, and it sometimes takes longer than the home inspection itself. So you really want to be careful about doing this.
It always takes longer. All right, thanks. So here's this is a little settling rate diagram, and it shows you, basically what it's telling you is that, big particles, 100 microns, settle out of the air very quickly, and small particles, a micron or less, can stay, permanently suspended in the air. So pollen particles are big; they settle out. You see always yellow dust in a lot of places on the, in the spring on the windowsills. So the problem with these Penicillium and Aspergillus spores is that they're small, so they remain airborne for a long time, and that's another reason why they can be more problematic. So here was some, let's see. Yeah, this was idiotic too. You can just read it. I mean, mold spores are so small, I don't know, they don't settle. They attach themselves to dust or moisture. I mean, there's so much ridiculous stuff. As I said, if you want to know about this more, I mean, you can read. We wrote a book called The Mold Survival Guide, and that really has a lot of, has a lot of what I'm saying here. So here's another problem. This is, maybe some of you know Terry Brennan. He's an indoor air quality person, but he does some microscopy too. But he took identical slides and sent them out to 10 or whatever, 9 different labs. And these are the results for the labs. So look at the difference. Here, purple is PennAS. Lab 1 said it was like, 2,500 or 3,000, and Lab 3 puts it down here. And you can see it's all over the board. And so the point is that there are a lot of labs that are like completely incompetent. And you have to send it to a decent lab. If you're going to the low-price one, you could be really getting screwed. Your information is really worthless. And a lot of times, Basidio are small. They look like PennAS sometimes. And if you're, I might take 20 minutes to a half an hour to do a slide. And if you're in a lab that's doing thousands of samples a day, you can't afford to take the time. And so they misidentify things. Look, this one said ascospores was, 10,000, and it's the highest. So this has been done by 4 different people, this experiment, and it came out the same every time, that most of the labs got very, very different results. And you want a lab that looks at the whole trace. Sometimes, the labs with a big volume, they look at 10% of the trace. It's just meaningless. Spores are totally non-sort of homogeneously distributed on a slide. You might see 100 PennAS spores in one spot. And if they don't happen to look at that part of the slide, then there's no PennAS available, no count. And this is the same thing, just showing differences. So again, this isn't just a little rarity. This has been repeated by several different investigators, and it always comes out this way. So this is a good example. This woman took I don't know if it was a tape sample. She sent it to some lab in Florida, and that's what the ceiling looked like. And they told her it was Stachybotrys mold, and she had to move out of her house. So she's living in a trailer in her driveway. And when I went, one of the TV stations wanted to do a story on the house. And that's just, all that is soot, candles. She was burning candles. And of course, she wouldn't admit it. if you people have candle soot issues like this, remember to look in the refrigerator and the toilet tank, because you might find the candle there. They hide them. What? So that was just, temperature anomalies. It's called thermal, telegraphing. So here's why you can sort of screw up like that. This is highly magnified. That's actually lacquer. That's a lacquer. When you spray paint or lacquer, you see spheres, and there's a spore. They look very similar. These are spray paint spheres, and there's some spores here. So I actually had one remediator. He was going crazy. They kept telling he failed the post remediation twice, and the third time they wanted. So he sent me tape samples, and the lab was identifying spray paint as aspergillus. They look very similar. The way I can distinguish is if you shine a light from the top, you do a reflection, the spray paint is usually white, and it's not mold. Here was another interesting one. This is, I don't know, we don't have that much time, but if you look at the data here, this guy, there was high basidiospores in the bathroom compared to outdoors. And this was a tiled bathroom. It was shower tile, walls tile, floor tile. And so the basidiospores were high. Now I told you basidiospores are mushroom spores. And that it's just ridiculous. So he said, there's contamination in the master bathroom, and here's the company. They can demolish the bathroom for you. This is like a beautiful tiled bathroom. They ripped the whole thing apart because the basidiospore count, which is mushroom. So the guy, I knew him. I had done some work for him before. He was actually a Supreme Court judge, and he said, "What do I do?" And I said, "This is ridiculous. It's mushroom spores. You don't have any mushrooms in your bathroom." And he didn't. So they didn't do anything. There was nothing wrong. Yeah.
When we take the air sampling, should we run the furnace blowers on manual while we're doing that?
Good question. So when I do all my initial sampling with everything off, and then I will take a sample directly on a register, because that's how I can distinguish if the mold is coming from the system or not. And I have actually I think I talk about that shortly. So you want to, as I said, for the lab, you want to insist that they indicate if the penicillium spores are in clusters or chains, because that's where all of your important information is. So here's, outdoor spore. You see, like, there's a couple of Penas spores outdoors. That's an outdoor sample. And then this is what they look like indoors. Big clusters and chains of spores. And if your indoor concentration is much less than your outdoor, but it's in chains or clusters, there's a mold problem, and you will completely miss it if you only do the comparison in to out. The other thing you'll see, and this is like to your question, this is an air sample coming out of a vent, and all of the spores are dirty. They have little black, that's like carbon from, that's either from soot or from, a lot of the lining material is black. It's got carbon particles on it, and so the mold gets full of carbon. So if you just count these spores up and it's less cladosporium than outdoors, there's no problem. But if you say that there's soot on the spores, you know that it's from indoor growth. Here's hyphae growing. These are, that's the hyphae of the mold, and that's got mold, soot on it as well. So one, and this is again going back to that question. So you can, if you have, a lot of times you can't get to the air conditioning coil. It could be completely full of mold, and so what I do is, here's two samples. I took this sample from the cladosporium, at the supply, and there's a couple of, cladosporium spores, and then I banged on the supply, and there's 27. So that's telling me that there's mold. So this is a really good tip. If you want to know if there's, mold in the system, you just go to the basement, and you can, tap gently around the coil. And if there's lining material or a lot of mold, you'll actually see some of those spores in your sample that you're taking at the supply. So that's been very, very helpful to me, because you can't get to the air conditioning coil. boy. So let's see I just want to talk, let's see, a little bit about surrogate allergens too. So you know that people can be allergic to latex, and one of the ways that they can actually get exposed to latex allergen is on the cornstarch granules that are in the rubber. So when you have anything latex, condoms included, there's always some powder, it's called donning powder, to keep the rubber from sticking to itself. And so what they finally realized, because they're having a lot of nurses were getting allergic to latex, what they discovered was that the cornstarch granules, which are very small, microscopic, they're in contact with the rubber, and they actually pick up the latex allergen from the rubber. And they then become what's called a surrogate allergen, because when you look under the microscope, all you see is a cornstarch granule, but in fact that cornstarch granule may be covered with latex, and the only way to test for that is actually to use a latex test. So they found, these are some other papers, like pollen allergen has been found, and cat allergen has been found on soot particles. Let's say you have a cat, and the cat danders in the house, and then there's some soot in the house, and the soot lands on the dander particle, and if it gets re-aerosolized, it can actually have allergen on it. So the other thing about all pet dander is really surrogate allergen, because we emit all these skin scales, and pets do the same thing. They're emitting skin scales all the time. And most of the allergens, like dog and cat, they're water soluble, and so the allergens are secreted by the sebaceous glands, the glands in the skin, and that allergen gets onto the skin, and then when the skin flakes get into the air, you breathe them in, and that's the allergen. So a lot of things that we think about as being allergic actually are surrogate allergens. And here's something where you want to be concerned if you see this. This is an air conditioning coil, and this is the air conditioning coil in the winter, so it's part of the heating season. And here's the condensate tray, and it's full of all rust and all kinds of dried up microbial slime. And you can imagine, here's a micrograph actually of some rust particles, and they're very, very small, some of them, and they've been sitting in this microbial soup, all bacteria and mold, and all microorganisms. They secrete enzymes into the environment in order to digest things. And so the water all evaporates, and those enzymes now coat all of these small particles. So I was actually in a place, it was a computer center in a high-rise building, and I was in the room with all of the servers, and there was nothing but servers, metal floors, and I could hardly breathe in there. And they took an air sample. There was nothing in the air except rust particles. They have a huge humidification system because the relative humidity has to be 50% in the server room. They don't want to have any sparks. And so the humidifier system was contaminated, and rust was coming out of that system. And that was in the air, and it was very allergenic. And that's how I sort of got clued into this whole situation. So here's a pan in an air conditioning system, and you can actually see all these fine threads. Those are the hyphae, and that was in the dust there. So there's been a lot of microbial growth. Anytime you have water sitting in a puddle and you have dust, you're going to get mold or bacteria or yeast, and that's the smell. Every time you turn the air conditioning system on, it always stinks. And that's because of all the microbial growth. So, let's see. Don't have a whole lot of time. Okay, we're going to finish. Good. All right, so has any of you done an ERMI test? Nobody. Okay, good. Oh, you have? Okay. Yeah, question.
Yeah, this is a quick question in a parallel to the cooling system. For the AC, the fridge. So with the refrigerator in the kitchen, do you find that there's often growth or high mold spores in relation to issues with the refrigerator?
Yeah. Okay. I've actually all of the refrigerators today are frost free, and what happens is that every 4 or 5 hours there's a defrost cycle. There's an electric heating thing in the freezer section. And every 4 or 5 hours that turns on. So you can imagine, this is a good point, that when you're cooling, you have air going through the refrigerator, and so the cooling coil is going to have a lot of frost buildup. And so what happens is the coil, actually this happened to me, was completely blocked with ice. I was getting no cooling whatsoever because my coil had burned out. So every 4 or 5 hours the heating coil turns on, it melts all the water that's on the coil, and then the water goes into a pan at the bottom of the refrigerator. Now, the heat from the compressor is directed over that pan and is supposed to evaporate all the water, but it never really evaporates all of the water. So you get incredible amounts of microbial growth in that tray. And I mean, we've had clients who just cleaned their refrigerator coils and tray, and that was the end of their allergy problems. So I got asthma from my refrigerator tray. I mean, I didn't even know at the time. I didn't know there was a tray. And I realized one day I realized every time I was getting, symptomatic, it was when the refrigerator turned on. So I pulled the tray out. It had been there for 3 years, never been cleaned. It still had the shipping tape. And there's a puddle of water in there, and there's an onion, a pearl onion, which was about this big, and it had green growth around it. It was penicillium, was about that big. And every time the damn thing turned on, it would kick out a whole bunch of that mold. So we tell every one of our clients that they have to clean the tray and the coils. And the unfortunate thing is that in all the new refrigerators, they don't have trays that you can pull in and out. You have to take a panel off the back, and then the drip pan is built into the bottom of the refrigerator case, and there's compressors and bolts and copper tubing. You could kill yourself even trying to clean it. It's really sad. But I've had a lot of clients who were very sick from just the emissions from that. I mean, the key is whenever you have airflow and water and dust, you're going to have problems. So humidifiers are a problem. Air conditioners.
Hey, Jeff, real quick. Getting back to just real quick. When we all see mold in the attic, okay, we all see it all the time.
Right.
Is there any value in recommending professional mold remediation in an attic?
Yes. I'll tell you why. This is what I tell all my clients is I say, look, you've got, this is, people that have been living in their house for a few years. I say, look, you've got mold in your attic, and if you want to sell the house, it's going to become an issue. So it's not causing any health symptoms, nothing's being destroyed, but you're going to have to pay for this sometime or another. And if they have air conditioning in the attic, then they may actually be having some issues with
Really? I mean, the only thing we usually see is the lamination of the plywood decking, which is really not the microfungi.
Okay, if you see, that's different. Okay.
But that's not the microfungi. That has nothing to do with the mold. It's just a symptom of the fact that there's moisture in the attic warping, delaminating the plywood.
Correct. Yeah,
right? It's got nothing to do with, like, remote remediation is not going to fix that.
Well, we always tell people, I mean, you have to stop the moisture issue. That's the problem. That's really the key.
That's just a symptom of the root cause.
Yeah, absolutely. But if the mold is only growing on the surface of the plywood, there is an exception to that, and that is because I had this oriented strand board, and it was all, that same thing was like delaminating, whatever, coming apart. And when I looked under the microscope, what I did was I took layers of OSB. I took, tape samples going down, and there was hyphae everywhere. Because the difference is that, solid wood has lignin, it has a very definite structure, and the hyphae from the molds just cannot digest the cellulose there. But OSB is made from flakes, and they're all pressed together. When you look under the microscope at the OSB, what you see is a little chip of wood, and there's like 2 or 3 little dots of glue. They just spray it here and there. And if you remember, 3 points determine a plane, right? I mean, if you have like a duct with 1 screw, it goes all over. 2 screws, it'll rotate on an axis. 3 screws, it's rigid. So every flake is attached to other flakes by little dots of glue. So when moisture gets in there, the wood swells and the glue disconnects, and it's just like cornflakes. But mold can grow because the hyphae can go around the little pieces of stuff because they're still only growing on surface, really, not growing into solid wood. So you'll often see OSB very, very deteriorated, and there actually is mold growing there, and it's actually inside the OSB. But that's why, because it's not a solid piece of wood. Yeah.
We've done a lot of testing around air patterns, air flows, and if there is the presence of mold in the attic, does it get to the living space? We have found from time to time when you have heavy wind with downdrafts, you can get that mold migrating into the living space, although not very often. And I think you're right that it's not something you're going to find commonly. But if you're in an area of the country where you have heavy wind, where you can get some downdrafts, say it goes around the chimney down to the basement area, or through an access hatch that isn't insulated, it isn't covered very well, our testing has showed from time to time you will get some spores migrating down to the living areas, but not very often and not as a growth pattern.
Absolutely. And also, I tell you, what I've seen, if you have, imagine you have a whole house fan, and, when you have a whole house fan, you're pressurizing the attic. There's never enough ventilation, so the attic is very pressurized. I actually took an air sample at a vent for the air conditioning with the blower off and with the blower on, and with the whole house fan on, there was 30% of airflow compared to the blower running. So the attic was pressurized, the duct system and the unit was leaky, and it was pushing air. So if you're disturbing all that junk, you certainly can have some, big exposures.
Absolutely.
Yeah, or the whole house fan. I was in one place where they had a very moldy basement. She opened all the windows. This is how we do it. And we turned the thing on, and the whole house smelled from the basement because the air pressure in the house was so much less than the pressure in the basement. So they're getting a lot of exposure that way. So you can certainly have exposure from an attic. I didn't want to say you couldn't, and there are definitely circumstances in which you could have a lot of exposure, but it's not, typical. So ERMI is a new test now. People are doing it. I get a lot of calls from people. They do an ERMI test, and it stands for Environmental Relative Moldiness Index. And it was developed by the EPA, and it's licensed to a bunch of labs. And they do a certain type of analysis. It's called mold-specific quantitative polymerase chain reaction. And what they're basically looking for is DNA. And they can then determine the species of molds. And the problem is, let's see, do I have that? This is how they developed their scale. They took 1,000 homes, they divided them into reference and moldy homes, and then they looked at the molds that were in the moldy houses, called them Group 1, and it was pretty arbitrary, and then they looked at the reference houses and called them Group 2. And then they determined this index by subtracting the logarithm of the Group 2 from the Group 1 concentrations. And what they developed with this scale, so, I get calls. I just had an email today, actually, from somebody who did an ERMI test, and they said, boy, our number is 14. It's really, really high. The way they developed this scale is by taking a vacuum dust sample from a carpet in the living room and in the bedroom, 2 square meters, and they developed the scale. But the way most people do this ERMI test is they take a cloth and they go all over the house and they rub the dust with it, and then they get their ERMI number back, and say, oh, we're 14, we have this terrible problem, but it's really meaningless. This scale was developed very specifically for carpet, period. So if you have a cloth that you've wiped all over the house, it will tell you the species of mold. It's very useful for that, but to put it on the actual scale is completely meaningless. So, and you will note that the bad molds in ERMI, they're mostly Aspergillus type of molds and Penicillium. So that's what I've been saying, is that the PENAS count is really, really what's important in your spore trap samples. and if you get a high, I should say that, I don't know if you get a high count outside of PENASP, it's wrong. The lab is wrong. It's never more than 5% of the total outdoor spores. So they frequently have errors. And So these are the good molds, supposedly. And Alternaria alternata, that's always outdoor. Epicoccum is always outdoors. But the Cladosporium cladosporioides grows on air conditioning systems. Thank you. So if you have Cladosporium cladosporioides, it might be coming from the air conditioning, but it's considered a good mold. So even, internally, this ERMI thing can have some problems. So there's another test called PCR, and it's the same idea. Oh, look, it didn't come. You can get the species. I don't know why that came out blank. Oh, there it is. Oh, I see. That's funny. Okay, so you get fungi relative abundance. You can get allergen identification to the species level, quantitative comparison, diversity. It's great stuff. And it's a new kind of testing where you can see the DNA of whatever was growing in the dust, but you can't put that on that scale. And this is an example using bacteria. It's kind of funny where they took swab samples and analyzed them by PCR. And here's on a doorknob, the pink. You see, if you look here, all the bacteria come from the skin. And if you look at like a toilet seat, the red, you got skin and then red, which is from the gut, and then yellow is urine. And I like to get the colors right. So you can, gives you an idea, and this is just in its infancy really, but maybe one day you guys won't, you won't be doing any of that spore trap. They'll just be doing this. I don't know. It's a while. It's still very experimental. Let's see. We actually made it. So you don't need that. And so we got a couple of seconds for questions. But if you want to know about mold, I would really strongly recommend Survival Guide. We have a newsletter we send out to home inspectors. So if you leave your card here, it's like a quarterly newsletter. You can we'll put you on the mailing list. We got a lot of home inspectors that get it.
As we're wrapping up, before you take your last couple of questions, on your seats you have those yellow yellow pieces of paper. Please fill them out. Leave them on your chair. But this way we can evaluate our speakers so we know that this is something that you may want them to come back and elaborate next year, or if we can get maybe other speakers on the same topic if this is what you're looking for. But please do fill out these gold pieces of paper. We are going to take some more questions, and we have about 6 minutes left.
Yeah, and if you ever have questions, you can call or email me. And here's the business card up here if anybody wants that. But I do get a lot of questions from home inspectors, and no charge. Yeah, anything? The best way to test for mold in a rug. What I do is I just take that pat sample, and you can do it with your, aerosol. By the way, I give another one on fiberglass this afternoon, but you can just tap it and then collect it. Or you can do a vacuum sample. Just vacuum it up and send it off to a lab. That little cassette. But you have to do a lot of areas, because if it's in a basement, it's worse at the perimeter. Good. How'd it go? Go all right? Good. Go all right? Thank you. Thanks. Good info?
Good info.
Yeah, good.
Jeff, what I do, I go around, I told you, figure out what's wrong, why it's wrong, how it's wrong. You did it
right. Same idea, yeah.
But I'm not a home inspector.
No, I know. Yeah.
But if you ever have a moisture deal somewhere, there's my card.
Okay, sure.
Yeah, that's my expertise.
Okay.
Yeah.
Quick question.
Yeah, thanks. Yeah.
Great job.
Thank you.
Good. A lot of times I see on new construction they bring in old mold or growth on the joists.
Right.
And I always tell the clients, you just want it gone, because if you go to resell
you just want to what?
You just want it taken off, because if you go to resell the house, it could become an issue when somebody else calls it out.
Yeah.
Is that the right approach?
Well, yeah, you can, they allow, the building, whatever it is, they allow a certain amount of its ophistoma. There's a couple of different molds that they allow. on the wood. So it's not really an issue. But if it's really obvious and it looks bad, you should probably just bleach it with peroxide or something. Just get rid of it.
A lot of times it's just dead. I mean,
it's always dead. Yeah, it's always dead.
So you okay?
I mean, it could be if it's the. See, the thing is, there's two things that happen when you. I've taken samples of framing. I didn't know. Actually this afternoon I have a picture of new construction, new house, condos right next to me, and I went into the basement and there was penicillium, that fuzz growing on the joists because they didn't dehumidify. So the if you get a few little black spots in the wood and it's in the grain, it's been there. But if it's on the surface, it may have grown. But it could have been storage. Like you see often where the wood's piled together and it gets damp and it gets moldy. And
then you mark it up at that point.
Yeah, you can clean it.
I don't know. I'm just trying to cover my ass at the end of the day. When I see something like that, I'm just trying to think, how do I word it so that I'm not freaking out everybody? Because I know it's not even alive. Because
it's come in. Well, the way I said that there's mold on the framing, and it looks, it's come in with the wood when it was
construction type.
Lumberyard.
Yeah, lumberyard.
Realtors now think of, it's just lumberyard mold.
Everything.
That's not a type.
Up, you can tell, but if you're sure that it's something that's not growing, and then you want to tell them to run a dehumidifier, keep the relative humidity under 50%, and you'll never have any growing anything.
Okay.
Yeah.
Thank you very much.
Yeah, thanks.
Pest control company sees that inactive fungi on the joist.
Yeah.
Required to have a structural engineer.
Really? Oh, that's idiotic. That's you have no understanding. Yeah, that's pathetic. Well, you can see the stuff on the internet, all the nonsense. I mean, it's just unbelievable.
And that's how I identify it. It's just inactive fungi. Is that correct?
Well, you can't say inactive. You don't know. Or just say it's it's mold and maybe it's old, but that's all. But that's sad. They get a structural engineer. Oh my God. Well, I guess the assumption is that if there's mold, there's moisture, and maybe there's wood decay. Maybe, but you see that. I mean, it's so different. Sad. Right. Thanks.
I'm probably gonna get at least one or two of those books because I think it's important. But I noticed the dates. One of them was.
Yeah, they're off 2000.
2004.
Yeah.
Is there a lot of? Is there much updating that's been done since then in terms of?
No, that's something. No, not really. No, the only thing that's new is that ERMI.
Yeah.
Go ahead.
Some